Hey, what's up, chemistry lovers? Me, Ty, and four of my classmates, Olivia, Teo, Ryan, and Jensen, are going to tell you about the particles in an atom, also known as the atomic structure.
Guys, so subatomic particles. Subatomic particles are the particles that make up the nucleus of an atom, and they consist of protons and neutrons. So if you look at this diagram right here, you can see that I marked the dark dots neutrons and the white dots the protons, and they basically make up the nucleus in the center right here. And the outside, you can see that it's composed of electrons, and I'll go over that in just a sec. So the protons are important because they have a plus charge right here, while neutrons have no charge. And let's see, protons, basically the number of protons is also important because they also make up the atomic number in the periodic table. And the neutrons also are important because they contribute to the atomic mass. So by looking at the protons and by looking at the atomic mass in the periodic table, you can also figure out the amount of neutrons. But protons and neutrons aren't the only subatomic particles in atoms. We also have electrons, which are important because they have a minus charge, which equals out with the proton's plus charge, and which is why unless an atom becomes an ion, they keep a neutral charge. And also, one thing you might want to know about electrons are that they are so small and so light that their mass is virtually zero. And when you guys do math, that's why most of the mass of an atom comes from protons and neutrons. And by looking at the diagram, you can see most of the electrons kind of orbit around the nucleus, and they form this thing called the electron cloud, also known as the orbitals.
Next, Olivia will show you how to write the symbol of a sodium atom and its mass of 23. Then she'll talk about its isotopes. Try not to get confused.
Okay, so this is how to write the symbol of an atom. X is the element, and then A is the mass number, and Z is the number of protons. So, yeah, that's how you write the symbol of an atom. Okay, so, for example, this is how you write the symbol of sodium. Okay, sodium is the element. And the number 23 over here is the mass number. And the number 11 here is the atomic number, or is the atomic number, which is the number of protons. So isotopes are two atoms of the same element, but they have different masses because of the different amounts of neutrons they have. So for example, sodium 23 and sodium 24, they both have different masses because sodium 23 has 12 neutrons, but sodium 24 has 13 neutrons. But they still remain the same element because they have the same number of protons.
Jensen comes in tricky with a question. What is a charged atom? Do you know?
Hi, so today we're going to learn about charged atoms. And there are three forms of an atom. The first one is neutral. And that means that the number of protons and electrons are the same. And the second form of an atom is an anion, when the number of electrons are greater than the number of protons. And the third form is a cation, when the number of protons are greater than the number of electrons. Please stop the video.
Then he'll break it down a little and show you how to find the protons, neutrons, and electrons in the mass and the atomic number.
Hi, so to test your knowledge, I will ask you how many of each of the subatomic particles are in sulfur -2. And to refresh your memory, subatomic means protons, neutrons, and electrons. And the bottom number represents the atomic number, the number of protons. So we will write that down first. And we'll get 16 protons. And the top number is the atomic mass, and that includes the protons and neutrons. So it will be subtract the protons and neutrons with the amount of protons. We'll get the number of neutrons. And then we get 17 neutrons. Now, sulfur usually doesn't have a charge, but this time on a question, it has -2 charge. And so if we have 16 electrons, the charge of sulfur will be 0, but we want to add an extra 2 electrons to give it a -2 charge. So 16 plus 2 is 18. Get 18 electrons.
Again, Teo will come at you with how to calculate the population average of an atom.
Hey guys, so what is a population average? So when you have two types of atoms in one group, and let's say the blue one is 10 grams, and the red one is 20 grams, what is the average mass of these two type of atoms as seen from the picture? So your first instinct might tell you that the average is 15 grams, but that's actually not true, because as you can see from here, we can see that the number of red atoms and the blue atoms are different. So there's actually a certain way we can do this to solve the problem. So you do 10 times the fraction, which is 0.25, and you add that with the 20 times 0.75, as seen from the picture. And this gives us 17.5.
Last but not least, Ryan will show you how to calculate the average atomic mass.
So the average atomic mass of an element that's shown on the periodic table happens to be the average mass of all naturally occurring isotopes of the element. So for an example, if an average atomic mass of Mg is, say, 24.3 U, then which one of these three would be the most expected to be the most abundant isotope? And just like deposit there. So the answer would happen to be A, because out of the three naturally occurring isotopes, A, 23.9U, would be the closest to 24.3, which only has a difference of 0.4 U instead of, like, say, 0.6 and 1.6 U here. Find the average atomic mass based off the masses of naturally occurring isotopes. You should find the sum of all the numbers of mass of the isotope times its fraction of abundance, or percentage of abundance in the world. So for example, for fictional element Z, there are three naturally occurring isotopes, and each comes with its correspondingly percentage of abundance. Try to find the average atomic mass based off these numbers and this formula. So here, I multiplied the mass by percentage of abundance, found each one's mass, or this number, and you simply just add them all together, and it adds up to 20.17 U. And that's the average atomic mass of the fictional element Z. Now, a common mistake is to find the mass of each isotope, but instead of multiplying them by the percentage, you just divide them by the number of isotopes. So you would add all these together and divide by 3. That would be incorrect, because that would be assuming each one is equal in abundance. So you divide them by 3 equal measures. But that's not the proper way, because each one has its own individual amount of abundance. So you have to make sure to avoid just finding the average and just instead multiply by how much there is of each mass and adding them all together. And you should find a number that is like somewhere in between all the isotopes available. And that's when you know you have the right answer.
Well, that about wraps it up for the atomic structure unit, and I hope you have a great time in chemistry.